Okay, today what we'll be discussing is a lab that we're going to do tomorrow, which is the ratios of Reactants Lab. Basically, a method for us to determine in what ratio do two reactants react together in a balanced chemical equation. We can test this using the method of continuous variation, in which we use varying ratios of one reactant versus another to find which one gives the maximum amount of products, okay? And so, as an example, I would like to discuss the reaction of actually hydrogen with oxygen to form water, okay? So, you may already know that the balanced chemical equation for this reaction involves two hydrogens reacting with one oxygen to give two waters, okay? Now, I'd like to show how this relates, this lab relates to limiting reagents, excess reagents, and theoretical yield. So you know that, let's see, two hydrogens react with one oxygen. If you took a pot full of 5 moles of hydrogen and 1 mole of oxygen, you would find that you would actually get, if you have a full reaction, that is all of your limiting reagent reacts, you would actually get 2 waters and you would still have a bit of hydrogen left over. You would still have a bit of hydrogen left over. Wow. My computer's very slow right now. Okay. Yeah, you would have 3 hydrogens left over. And so, if you were to use these ratios, what would be your limiting reagents? What would be all used up? Well, it would be that oxygen there. O2 is your limiting reagent. And what would be your excess reagent? There's some left over after the reaction is complete. Well, that's that hydrogen. Now, what is your theoretical yield? How much product should you get if all of your limiting reagent, that oxygen, reacts? Well, you should get 2 moles of water. Okay? You see that the amount of your product, your theoretical yield, is dependent upon how much of that limiting reagent was used up. You see, having 1 mole of oxygen, you should get 2 moles of water, and you see that here. Now, this is not the optimal ratio of reacting hydrogen to oxygen, because there is a lot of excess reagent left over. And so, you know, in our lab, what we'll be doing is not knowing how a reaction is balanced, we're going to try to find these coefficients in front of each reactant. And to do that, we're going to go ahead and see essentially which mixture or which ratio gives the most products formed, okay? So let's go ahead and test out some other ratios of these things and see how much product is formed in these cases. So let's see, reacting oxygen and hydrogen together again. We should get, let's see, 2 waters from each of these 2 hydrogens and 1 oxygen. So we should get a total of 4 waters. Isn't that interesting? Oh my gosh, there is no hydrogen or oxygen left over. This is the optimal ratio to mix this hydrogen and oxygen together. In fact, we get the most products when we have the ratio which is described in the balanced chemical equation. Okay, so that's essentially what you're looking for in our lab tomorrow. Which ratio gives that most products? And just as another example, say you were to react. Say you were to react 2 oxygen molecules with 4 hydrogen molecules. Well, actually, I'm sorry, what I meant was to react 3 oxygen molecules with 3 hydrogen molecules. Let's see. Two hydrogen molecules react with one O2. Actually, we're dealing with moles here. And 1 mole of hydrogen will react with half of a mole of oxygen. And so in this case, how many waters would you get? 2 from this guy and 1 from here. You would get a total of 3 waters. And you would also have 1.5 oxygens left over. Okay, so what is your limiting reagent? What determines how much of that water was formed? Because it's all used up? Well, that's the hydrogen. What is the excess reagent? You have more than you need. That's oxygen, O2. And your theoretical yield, well, that was those 3 moles of water. Okay. So let's use all of those tests to create a chart, which is a lot like the chart you'll have to build for your lab. Okay, so we're making here a graph of the number of moles of water formed versus essentially the ratio of oxygen to hydrogen. So what happened when we used, in our first test, 5 moles of hydrogen and 1 mole of oxygen? We got, or we should have gotten, 2 moles of water. Now, what if you used those 4 moles of hydrogen and 2 moles of oxygen in our second test? Well, you should have gotten 4 moles of water. And if you had used 3 of each, you would have gotten 3 moles of water. And so we collect data points in a variety of different ratios, and from that we're going to create some lines which should intersect. Let's create one more line here. You know that if there was no oxygen, you should get no water as well. So what you should do is get a ruler out, and you would create a line which goes roughly along all of those points, and then you would create another line which goes roughly along all the other points that you would collect. And where that line intersects, that describes the ideal ratio of those reactants together. That describes the ratio in a balanced chemical equation. This tells you the coefficients. And so that's really what we're testing for tomorrow. At which points do these 2 lines intersect? Which is the ideal ratio of reactants? What are the coefficients in the balanced chemical equation? Although in the lab tomorrow, actually, you're not testing water, you're going to be testing the reaction in some styrofoam cups. The reaction of a mixture of sodium hypochlorite solution, aka bleach, with another solution of some other compound which reacts with the bleach. And so you're going to be doing that in these cups, and you're going to have a thermometer which reads the temperature of that water. You're going to be keeping track of the temperature of the water versus the ratio of these 2 things. Now, you should get data which may look something like this. And where those lines intersect, that will again discuss the ideal ratio, i.e. describing the coefficients in the reaction between sodium hypochlorite, sodium hypochlorite and B. Now, we're using this graph, and we're using delta T, the change in temperature, which should describe the amount of heat which is released by this reaction. And that heat, by the way, is proportional to the extent of the reaction, or the amount of product formed. Okay, so we're tracking change in temperature versus all of these different ratios.